Hello, this is Stephen Withrow with Webicator. In this video, I will present a solution Malcolm Rowe came up with for deadlocks in Java class initialization. Malcolm has agreed to let us create a video about his solution, which is available as an article on his blog at the URL shown here. The deadlock is illustrated by a Java 7 program presented at the beginning of the blog. In this Java program, Malcolm creates a thread. In this thread, there is a call to a static method in a static inner class. In the static inner class, called a private static variable of type B is required. Next, Malcolm will create a reference to class B. In class B, a static method is called. The static method requires a reference to class A. Therefore, we have class B that requires class A and class A which requires class B. This is the deadly embrace or deadlock. Malcolm illustrates what's going to happen here. We compile the code, then we run the program, and nothing happens. Well, actually, the program hangs. We don't get any response back to the console. This is indicative of the deadlock. If the developer hits control break or control backslash, then a thread dump is going to be produced to the console. This indicates the location in the program where the two threads are in conflict. Malcolm points out that we don't have a convenient way of detecting when this is going to happen. We are, of course, aware of it when it does happen because the program is going to hang. I have reproduced Malcolm's code on my computer. I have a Java program called Deadlock Test. I have added a few system out printlns to help us see where the problem occurs. In my command prompt, I will run the program. I get a couple of messages to the console. The first one indicates that we have invoked the initMe method in class A, and this happens in the run method on the first thread. And then we call the initMe method in class B in the separate thread, and this is where execution hangs, as Malcolm has indicated in his blog. I'm going to hit the control break key. This gives us the thread dump. When we scroll back through the thread dump, we will see the locations in our program where the conflict occurs. So I get the line numbers, and based on those line numbers, I can go back to my code and see where the deadlock is occurring. In this case, based on the thread dump and on the system out printlns provided in the code, we know that the conflict occurs when we invoke the initMe method in class A in the first thread, and then we invoke the initMe method in class B on the second thread. Thanks again to Malcolm for the inspiration for this video. For other articles on programming techniques, visit his blog at the URL shown here.